Welcome again to Wickerson Studios. My name is Michael Wickerson, and I am just following up from my last video to put this in a nutshell and make it look a little simpler. And this is really what you're left with, say a dozen nodes that are actually running on C# scripts. And you can see here that I've had plenty to draw from. I'll put my little face over here. I think it's over there now. Every script in here, well, pretty much every script in here is a C# node script that you can go into and play with. And let's go into it. This is the final generation of a system that came out of something like this. It got pretty complex for a while. It grew to that complexity, and it started with this very simple template that I began with, this first generation template play. And this is kind of something I've invented for my students to get them thinking of C scripting, and I'm hoping it comes in handy. What they come from is my favorite nodes, and these happen to be all C nodes, C# nodes, which is kind of intimidating. People like icons, they don't like C scripts, and I drew that from RIICE of the Warsaw Technology University and others, and I've been playing with smaller scripts the whole time, but it's been hard to just kind of piecemeal one together and know all the nodes. So I think finding and starting with a template like this, which is basically dealing with nodes that dealt with data and numbers, iterations, then prime factors and some easy methods and constructors, then once again those iterations and recursion functions, and then on to vectors, recursion functions again, piping and making curves, recursion functions again, moving on to creating surfaces or manipulating the curves as different methods and functions, then more iterations, and then on to surfaces. And that's a little thing I've invented for myself that I can go into and start playing with, and you can see the play that's happening here. Some things are generated from gene pools, some are generated from points, there's another one from gene pools. So you slowly start creeping through this, and as it grows in complexity, you can take it to its final iteration. Red is not really a warning, it's just that's the complexity of what I ended up doing. Then I take the whole script and I take out everything that wasn't in use or was left hanging in the script, and I'm left with this. And there it is. So what I have here, if we take a look at this, I'll take it all and I'll put it all to visibility, preview on, and this is following the last video. You can see that I actually start with 4 points, this point, and I'll blow this up. Maybe I'll take off my ungroup. You can grab these 4 points. They're all manipulable. They change the form. They're driven by that. I merge them into a tool. I put them into get point coordinates. That's a simple function on C, which says make A at point X, B at point Y, and C at point Z. Very simple to run that function. Couldn't be simpler than that, I don't think. I'm finding the absolute value of that because I have to deal in a height. I'm putting that into a node of accessing a list in random class. And here's what happens here is you're basically creating a list. Well, you create a random seeded random thing to begin with, which is actually referred to as point tower in the script that I got it from. I'm going to shrink this down so we can see what's going on. And then I'm running it through an iteration of a while loop, which is less than height, which definitely tells you that it has to be, I'm making it absolute value positive, so it worked. And I'll have a translation which deals with the radiant angle and the vector axis, which I've created. And you'll see that inputted, and that should be up here, up in the top. And then I am appending that to the list and ending up with the data in a p-list. Let's close that out. And you're ending up with different data as it's processed through as a set of trees. And you can see that I have 4 sets, 7, 11, 5 items on each. Those points I'm taking in here, and I'm calling out an index, the last index, which is a double. I'm actually left with some pretty cool data here. Right here is points as this kind of curve that's being created. And I'm setting my point coordinates again because I want to get a hold of those. I want to build a vector out of those. And I don't have a vector display on here, which is something I should do. Let's just grab a quick vector display and see if I can pull that up and anchor that to all the points, which should be these point lists. I think that'll work, yeah. And then you have it's hard to see here if I get rid of that. There you go. You can see their vector point list, which is actually generating this form. That's the data and information that's doing it. We'll get rid of that, go back into the overall form. I'm finding curves. Actually, probably it's best to just go here and deal with that data. I'm finding curves between those vectors, which are very subtle and small, but I can amplify them. And I'm pulling a loft between them, and they're very small and subtle right here, but because the distance can be played with, I pulled it back here, which is kind of fun. I can actually make that pretty huge. Let me just see what happens here. Give it a second to run. That should have altered it. Hang on, let me follow my data back. My distance should have happened. Maybe it doesn't affect that one right now. What is my loft? Oh, there it is. Okay, I didn't have it clicked. As I play with that data, you can see that I can really transform this shape. and have this irregular kind of lofted surface. And I love this type of anamorphic complexities, which, it's still pretty purposeless and it's still pretty creative. You can see that I have a whole bunch of surfaces here. And what I've done there is I've blasted those curves apart again, drew a loft between it, ended up with that form, and then I've extracted the line, and just because it's red doesn't mean it's not giving me data. It's bringing in 3 untrimmed surfaces, and it's bringing me out 4, but you can see the first one has this one single item on it, so it won't run, but the other 2 are. And in having the other 2 run, I can just grab those outer curves, and I can throw those 2 and iterate loft between themselves, which really transforms kind of rotates the whole form as what's lofted in between the other rotations on the sides. So you can do anything with these geometries, make it solid or whatever. And this is kind of this extrude from normals, things that I used to do in Grasshopper all the time, if that's making any sense. And what I have is some really nice items, and certainly the odd numbers. I think they make some beautiful curves. And these are wonderful patterns that I like to use, especially the odd. And I can do more than one if I wanted to, but you'd have to play with the loft function. And then I'm calculating the volume of the centroid, which is definitely just a volume of a BREP. And I'm switching my surfaces over to BREPs and ending up with an orientation tool. So I'm orienting that on all of these forms. And you can see that complexity, fast running script. I love it. Go back to your distance, play with that from 2, make that a much thicker form as you go. You can see it's processing. It's like, oh, what am I doing? I'm becoming this fat, jostling, wonderful ribbon shape. And this is just optically, I find it very interesting. I actually like it kind of piddly and transparent to see through. And of course, you can take it through different iterations because I have a seated randomness on here. So as I start to roll this, you'll see that you end up with all these different kind of box structures. And I haven't even begun to edit the points. So I can make this a very interesting cluster if I didn't want something square or rectangular. Now, if you're thinking of facade of a building, or if you're thinking strange column work as to what you're doing, or something architecturally, and you're thinking within a box, this is a way to think inside the box, but infinitely within inside that box. And now I can just change the shape to allow it to be a little more transparent. So let's pull this one up on scale, so it's a little thicker and meatier, and then let's pull I believe what's that called? That's between the X and Y. That's basically the spacing. I think that's exactly what I called it, spacing across the surface. Oh, it's in one of these nodes. Target source. I thought I had it. Distance, tolerance, num, count, wrap, amplitude, seed, spacing. There's the spacing. That's actually, it's not having an effect by it. It's the seed that's having an effect by it. Anyway, that's the script. We'll take it through a different seed and see if I can't bump that up into some fat, big, high range. I like these facades. I kind of like it a little more Borg-like, which is always interesting, and then go back down to that piddly kind of ribbon tool of actually what's happening. The even numbers are a little more sparse, so the evens have a smaller section loft on them from the tops, I believe. So if you pull in a 1, you're going to get this very kind of, it's almost like characters. It's almost like letters or words, which I find very interesting. 3 is pretty minimal. Well, then again, I changed the seed, so it's hard for me to guess. Actually, the even numbers are much more sparse. You can see this. You have this kind of ribbon pattern, this tight pattern. So if you're thinking of a vertical, hung installation in multiple parts, that one's really tiny. 6 is, the same type of ribbon tool. But like I said, the odd numbers are a little more juicier, full, filled out, and can be an interesting shape. But there's the script, and it's actually not that intimidating. It's just created by, let's just count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 C# scripts, which are very close to the nodes that you're given, but you're starting to think a little differently. And of course, going into here, this is a great vector tool that even though the node itself I've brought in, I've had to customize it. So as I go in here and I look at the vector tool, which is vector operators, you'll see it comes in and it produces its own from a hard-coded vector. So really, I've just had to get in there, and what I did was just remove the hard-coded vector 3D here, and I guess I could do the vector 2, this vector v1 the same way if I wanted to bring it in as an input. I hope that makes sense to people, but you have to customize these nodes as you go. So you can't know nothing about C and just be pulling in plugins. Otherwise, you may as well be working off the ribbon shelf tool in Grasshopper and plugins. This is for the people that are actually interested in plugins, and I'm doing this all to practice so I get closer to being capable of making plugins. Purple and beautiful. Who doesn't like purple? I know my daughter loves it. And I'll just leave that and throw that back into that happy blue, which I've done on most of my videos, grouping it, coloring it, and saying, I always have trouble with this. put it into a nice blue, and I don't like that blue. I like that blue. And there you go. You've got your script that comes from all this research, which I'm starting to share online because I'm starting to customize things. And I think intellectually the property of these forms is mine. In a sense, the basic scripts, I don't know if you can own them. I really don't know who has the rights to this one. So do some modification, change it up, and label them and name them, and find your own way to customize your own programmable Grasshopper Node scripts. It's kind of fun to think about. And you'd be the only developer doing it and not really working as a full-fledged developer, but you can send these nodes out to people as you start to develop and customize them and make them yours. You certainly could take these again, which is kind of futile, and cluster this whole thing so it has an output and an input, but it's clustered by C# scripts. And that's getting a little crazy. You may as well be writing in Visual Script Studio and keeping that from people to see it. I'm in here for the play. I think it really is about a template, the green template, a first generation play, a second generation play, and then a final form of what you're actually happy with what you did. Nothing too complex geometrically. Well, yeah, I guess it is to some, but to me, it's I've done nothing but an orientation tool on some basic scripts. But I want to basically have an understanding more and more of C# and Rhino Common, and be able to go right back into the GH Python node, which I think a lot more people have interest in just by the 10 times the amount of people jumping into the Facebook private groups. Okay, under 12 minutes. Thanks for watching. Keep going.